Are you in Mr. Eng's math class and have missing assignment and don't know what to do? Well, I have the answer for you. Just do these.
Hey there class, this is Mr. Ivan and I'll be doing the solutions for version B of Module 2 test 2.1 to 2.5. Okay, so the first question is this graph, and every single question on 1 through 5 is about this graph. So the first thing is they're asking you about point C. Where is point C? Point C is right here in the middle. That's the origin. So the origin is the point that is on the x-axis and y-axis. So in reality, if you chose either x and y-axis or y, you should have gotten a half a point. But if you chose both, then this should have been the full point. Okay, for B to D, what's going on between B and D? B and D is down here, D is down here. Going from left to right, this is increasing, so I have to circle in increasing. Next up, I have B and D. What are they? Local max, local min, what are they? So I'm looking at D, and if you notice, point D, everything around it is lower, so that makes it a local max. So this is how I know that local max for point D. Next up, we have functions. How many zeros does it have? So in other words, zeros is also x-intercepts, and if you notice, I have 1, 2, 3 x-intercepts, so I have 3 zeros. Next up, asking about odd, either, neither, or even. So if you guys remember in class, we learned that a function can be symmetrical along an axis, and if you can fold it once, then that makes it an even function. So for example, if I fold this parabola along the y-axis, that means that this is even. But if I can fold it twice, for example, if I have a function like this, if I fold it this way and then I fold it again this way twice, that makes it an odd function. But even if I fold it twice for this one, I'm not going to get the exact same answer from one side to another, right? You notice that this is a little bit wider. This dip is a little bit wider than this one. So regardless of how many times you fold it, it's not going to be perfect. So this is neither. Next up, we have this function f of x equals negative 3x to the power of 8. So if I want to sketch this, I want to think about a rough sketch using 2 pieces of information. My degree for 1. Right, when my degree is 8, 8 is an even number. So when you have even numbers, your end behaviors are either both up or both down. The reason I know that it's actually both down is because my leading coefficient is a negative number. So I know that my end behaviors are both down. I'm not interested in what the details are in between, right? Because something could be going on in the middle. But I'm not really interested in that. I'm only interested in my end behaviors. Because that's all they're asking you. They're only asking you about what happens as x goes to negative infinity, right? As x goes to negative infinity, what happens? Your y goes down. So that means y would end up going down. So this is my answer. Negative infinity. Next up, we have this can-can. So when we're doing a can-can, so you got to make sure that this is the operation, not a negative. So it's asking you for 2 numbers that subtract for 3, 2 numbers that subtract and give you 3. So the first one, 2 that giveaways are this, 3 and 4, because they're the only numbers inside that one entry. So I want to first fill out this column. So I have to use up 1, 3, and 2. And I'm going to choose 2 numbers here that add up to 5. I can maybe choose 3 and 2. So I'm going to choose 2 and 3, no particular order. I can swap them if I want to. So I'm just going to leave them like that for now. Next up, I want to fill out these 2 numbers that add up to 3. I can use up maybe 2 and 1. But I'm not going to put 2 here because then I'm going to repeat. So I can maybe use 2 and 1 on this side, which means that this has to be 4 because I haven't used it yet. And then 4 minus something gives me 3. That's 1. Next up, I want to fill out these two numbers. So I haven't used 3 and 2 in that column. So let's go ahead and maybe put 2 and 3. The reason why I put 2 and not 3 is because I would avoid repetition of 3. Next up, I want to fill out these two. I can maybe use 2 and 1 because I haven't used those two. So let's put 2 and 1 because I want to avoid repetition of 2. And then let's figure out what happens here. I want to use 4 and 1. Put 4 here, 1 here to avoid repetition. And then lastly, maybe put 4 and 3 because I want to avoid repetition of 4 and repetition of 3. And that should be my answer. You can double check, but I think that's right. Next up, we have this question over here. So they're asking about the leading coefficient. So leading coefficient, in order to find out what that is, you want to first find the biggest exponent. Once I find the biggest exponent, in this case 6, you want to identify the number in front of that term. So in this case, my number in front of this term is -1. So my leading coefficient is -1. You cannot let the order of the numbers of the terms confuse you. Even though this is the first term, it's not the leading coefficient. Okay, next up, we have this question. So they're asking you about using this table. So what I like to do is I like to sketch this. So let's go ahead and try to sketch. So if I sketch this, I can go ahead and maybe write down some points. I can use -2, -1, 0, 1, 2. The first point is -2, 4, so let's pretend it's somewhere up here. -1, -13, let's pretend it's somewhere down here. 0, 0 is the origin. 1, -7 is way down here. And then we have 2, +4 is going to be somewhere up here. And then lastly, we have 3, +45 is way up here. So let's go ahead and try to connect these dots. So if I try to connect them, you'll see that you get something along the lines of this. Doesn't have to be perfect, but as long as you get the idea that we have two dips, right? We have this dip and we have this one. So these two are two minimums. One is less than the other, right? So actually, I think I might have sketched this one a little bit wrong. This one has to be less, because at 1 we have -7, which is slightly bigger than this one. So this one should be a little bit more up here. But regardless, they're both minimums. But it's still important to know that which one is smaller than the other. In this case, this point when x equals -1 is less. So the absolute min would end up being at x equals -1 is the absolute min. Well, this one right here, when x equals +1, is the local min. And one thing that we mentioned in class is that absolute min is, of course, what the title says, it's the lowest point. And the local min is not as small as the absolute min, but it's still min. So one way you can think about this is noticing that every single local min, or I should say an absolute max, absolute min is also a local min, but a local min is not an absolute min. So because they're actually just asking you to find the relative min or local min, you could have actually chose either one of these two, because an absolute min is also a local min, but it's not true the other way around. So as long as you chose either one of these two, then you got the answer right, -1 and +1. So let's go ahead and move on to the next one. So polynomials, if you want to test if something is polynomial or not, polynomials cannot have exponents that are fractions or negatives. So let's try to avoid something that has a fraction or a negative as its exponent. This is not a fraction or negative, so this is a polynomial. Exponents of this one. This one checks off, but this one does not check off because 3 over x is the same thing as 3 times x to the negative 1. We have a negative exponent, so that means this is not a polynomial. Moving on to the next question. They're just asking us to simplify. So 5x to the power 6 minus 2x to the power 6 gives me 3x to the power 6. Negative 3x to the fourth minus 4x to the power 4 gives me negative 7x to the power 4 because I distribute the negative. Next up I have 2x squared minus plus 7x squared because I'm distributing this negative. So negative 3 plus 7 gives me positive 4x squared. And without doing the last one, I can already tell which one is going to be. Let's see if I did this one right. It's positive 7, yeah, 4x squared. 4x squared. Oh no, hold on. I think I made a mistake here. So the second term ends up being negative 3 minus gives me 7. 2 plus 7 gives me 9. So my mistake, this is actually positive 9x squared. So without doing the last one, I can already tell that this is my answer. Okay. Next up, we can go to the back. All right, so this one, 3x minus 2 to the power 4, you could have solved this multiple ways. I've seen some students using the box method. You could have done that. You could have done the box method repetitions. But I'm going to show you using the binomial theorem. So binomial theorem, if you remember, you have to use this formula right here. A plus b to the power of n. In this case, n is 4. And we have to figure out what a and b are. So let's try to figure that out. I noticed that a can probably just match up with 3x. That's probably an easy dead giveaway. So a is just 3x. To figure out what b is supposed to be positive. However, you can rewrite this as 3x plus negative 2 to the power of 4. So in reality, my b is actually just this negative 2. So b is equal to negative 2. Okay. Next up, I have to rewrite my coefficients. So I have to write my coefficients. In order to find out what the coefficients are, I have to use my Pascal triangle. So Pascal triangle, I wrote down the first few rows. And if you remember, this is exponent 0, exponent 1, 2, 3, 4. I stop here because my exponent is 4. Right? So my exponent is 4, so that's where I stop. So since my exponent is 4, I want to use these as my coefficients, 1, 4, 6, 4, 1. So once I write down my coefficients, attached to those coefficients are a times b, a times b. And you have to remember that a starts off with a high exponent and eventually crashes down to the power of 3, to the power of 2, a to the power of 1, a to the power of 0, and the opposite is happening for b's. It starts off with to the power of 0 and then eventually climbs up to b to the power of 4. We say that it stops at 4 because this is my highest exponent. The one that they give us in this case is 4. So now that I have this written down, I have to substitute my a and b. But we have to be careful when we substitute a and b because in this case, we want to use parentheses when we're substituting because everything inside here is the value of b. Not just 2, but negative, for in this case b. Not just 3 and not just x. Both of them represent a. So when I use parentheses, when I substitute, this is what I mean by using parentheses. When you're raising a to the power of 4, for example, you want to apply the exponent to both 3 and x. You want to apply the exponent 0 to both the negative and the 2, and so on. You keep using this exact same substitution, raising the power to every single thing inside a and b. Because a represents, in this case, 3x, and b represents negative 2. So once you have successfully substituted a and b, all you have to do is just simplify it. So anything to the power of 0, in this case, just becomes 1. So the first term is just 3x to the power of 4, which in this case I think it's 81, x to the power of 4. And you just keep repeating the exact same process, just simplifying. So you have to be very careful, especially with the signs. So in some cases you can tell that when you raise a negative to an even power, it stays positive. When you raise a negative to an odd power, it becomes negative. So you just gotta be careful about that sign, and as long as you got this answer, being careful with the signs and parentheses, keeping it consistent, then you should have gotten this answer. Some students got this exact same answer using repetition of Xbox, of the box method, and that's fine, you still got full points, but just keep in mind there's more ways to solve this problem. Okay, let's move on to the second to last question. Division. Alright, so division. Let's use synthetic division. So if I use synthetic division, I want to find out what goes out here first. So what goes out here is you take the divisor, in this case x minus 2, set it equal to 0, which means that x equals 2. This is the number that goes out here. Next up, I want to find out what goes all the way up here. Those are my coefficients. So my first coefficient is 1, right? It's right here. So 1 goes in here. My next coefficient you may think it's -1, but it's not. Because in reality, I do have an x to the power of 3. Right? It's an invisible x to the power of 3, but its coefficient is 0. That's why it's invisible, because 0 times anything is just 0. So that one was kind of tricky. So in reality, I have 0, then -1, then -5, then -2. Drop down my first number, 1, multiply across, gives me 2, add, gives me 2, multiply across, gives me 4, I add, gives me 3, multiply gives me 6, add gives me 1, multiply gives me 2, and then lastly, when I add these, it gives me a remainder 0. So my final answer has to be in degree less than 1 degree less than the dividends. So in this case, I have 1 times x to the power of 3 plus 2x squared plus 3x plus 1 plus remainder 0 all over x minus 2. And this is my final answer. You could have also solved this using the reverse box method. So if you use the reverse box method, you could have had x minus 2, I believe, and then x to the power 4. So these are givens, right? This is my divisor, and this is the first term from my dividends. Okay, so first thing I want to do is I want to find out what this is. X times x cubed gives me x to the power 4. This means this is -2x cubed. I want to find out these diagonals that add up to 0x cubed. Right, so in order to get 0x cubed, this has to be positive 2x cubed, right? Because they both cancel each other out. So that means this is 2x squared, and this is -4x squared. Next up, I want to get something, the x squared to add up to a negative, right? -x squared. So that means this has to be a positive 3x squared, which means that this is 3x, this is -6x. I have to extend this box a little bit more. And lastly, I have to add up to -5x. So these diagonals add up to -5x, which means that this is positive x, which means that this is 1 and this is -2. And which means that my remainder, if you notice, this last term should match this last term, which means that my remainder is actually 0. And finally, my answer is this stuff on the side, plus remainder. So it's x cubed plus 2x squared plus 3x plus 1 plus remainder 0 all over my divisor. And this is my final answer, which matches what I have up here. Okay, last question. They're asking me to sketch this. So pieces of information. I have zeros at 0, 1, 3, and negative 3. So let's pretend this is 0, 0. And this is negative 3, 0. And this is positive 3, 0. Right? So this is negative 3, positive 3. Next up, I want to look at my end behaviors. As x approaches positive infinity, what happens to my y? It goes up to positive infinity. So as I go this direction, my y goes up. So I'm going to go ahead and just leave it like that. And if I go the opposite direction, right, as x goes to negative infinity, y goes down. So if I go this direction, my y eventually crashes down. And I'm just going to leave the end behaviors like that for now. And then lastly, it's asking us to consider the fact that the maximum, relative maximum, is about x equals negative 1.7, and the relative minimum is x approximately 1.7. So I can just kind of pick and choose where somewhere along 1.7 is around here, and negative 1.7 is somewhere along right here. I can maybe pretend, guesstimate, maybe, let's just say one of the points is right here, right? Let's just pretend the other point is somewhere around here. And lastly, I just had to connect the dots. Let's just see if I got that right. Relative minimum, oh my bad, relative maximum at negative 1.7. Okay, so it's the opposite. So I just need to remove these. So I just want to swap them. So this one now goes down, this one goes up. Because I have a relative max at negative 1.7 and the relative min at positive 1.7. This is why I swapped them. So now I can just fill in the blank. So I can just connect these, and I can go like this, and like this, and eventually just goes like that. Again, it doesn't have to be perfect. As long as you get the idea, you get something that looks like this. And that's pretty much my graph. I hope this video was helpful, and I'll see you guys in class. Bye.
Gather around, let me tell you about Mr. Eng. He's the math maestro, got that stat slang in the classroom. He drops knowledge bombs, equations flying like beats, setting off alarms.